Hello everyone, my name is Zach, and today I'm going to be talking to you guys about how to get your program to work autonomously, as well as another method for starting your code on its own that, since some people had some issues with the way I showed in the previous programming video. Now, for this alternate method of starting your program on boot up, you want to make sure you're on the latest version of the Raspberry Pi operating system. The version that ran from the end of October through the end of January had some issues with it, and one of the issues stopped us from using this method, which is why I showed the other one in the first video. However, some people have said they've had problems with it. So what you're going to want to do is either click the little download button in the top corner if it's there for you, or run some commands to update your Pi, or you can even just download the newest version off their website. Or you can do what I did, which this is actually a release from 2020, so 2 years ago, before it broke itself. So I just went back to an old one, or you can just go to the newest one. That said, you want to open up your folders here and right click and hit show hidden, and some other folders should appear, including .config. Inside of here, we're going to create a new folder called autostart, A-U-T-O-S-T-A-R-T, all lowercase, has to be exact. And inside, we're going to create a new file that's going to be a .desktop file. I don't know why I can't click. Okay, it appears to have crashed. If that happens, you just do ps-ef pipe to grep, and then we're going to search for pcman-fm. And then sudo kill-9, and then the number that comes up with it, which is 667. And that killed it. So it crashed on me, so we had to do that to restart it. There's a little trick for you if something crashes. All right, and then we're going to do .config, auto start. Anyways, this is the folder we just created. In here, we're going to do a new file, and we're just going to call it boot.desktop. And we're going to edit it real quick. And you want to put this inside of the code. So it should say desktop entry, type equals application, terminal equals true, exec is equal to Python 3, and then the location of your code. Mine, as you can tell, is in /home/pi/documents, so it's in the documents folder, and then it's called robot.py, which is exactly what this says here. And then name is equal to booter, or you can call it whatever you want. This is just how I set mine up. This is the general template you need to follow. Now, right here, we'll go back to the AutoStart folder. Let me refresh this. Actually, I might just need to reopen it. I don't know if it'll take effect yet. But once you restart, it'll actually change the name of this. So it's still going to be called boot.desktop. But if you look at it, it'll actually say booter, because that's what you set the name to. So next time you restart, if it's called booter instead of boot.desktop, that is completely normal. But if you actually notice, we can run the file. So we're just going to hit execute. And it's starting our code. Now, because we put this in the auto start folder, this should start your code when you turn on the Pi. The only issue is it only runs the auto start folder stuff when you're hooked up to a monitor. So we have to make our program think it's hooked up to a monitor. And this is actually the part that was broken in that version. You want to go to Raspberry Pi configuration, and then display. And in my case, I'm going to do set resolution because I'm running the old version. I believe on the newest version, it actually is called headless resolution. And you can select whatever you want. In my case, I'm just going to do 1920 by 1080p at 30 hertz. That works. I believe headless resolution doesn't have all of these options. I would just select 1920 by 1080 and hit OK. And it's going to ask you to reboot. And this is actually a good time to test. So I'm just going to hit reboot and switch my camera to where you can see the robot instead of the screen. And without doing anything, let me actually unplug the monitor here. So you can see this is running without a monitor, just a robot on its own. It should start up the code like we told it to. It does take it a moment. Normally, you can tell by the motor controllers when the lights turn orange. That means your code is ready to run. But in my case, they were already orange since I just rebooted from the Pi rather than using the switch here. But as you can see, I have full robot control from the moment it's turned on. This should be a bit more reliable than the other method. if you set upright and make sure you've done all the correct steps. Now, we're going to go back to the Pi here. I'm going to plug in a monitor. And we'll switch back to monitor view. There we go. Let me see what's going on here. Please change it to any other listed, blah, blah, blah. Okay, hold on. So it turns out the mode that I set, the 1920 by 1080p at 30, is not supported by my monitor. So we're just going to go back and we're going to change it to one that is. So that's the only issue. Where is it? It's in preferences. There it is, configuration. You just want to make sure it's one that your monitor actually works with. So let's see, display. This will be harder for you guys probably if your monitor doesn't work, because I can still see mine without the monitor. If you don't have a monitor, you probably can't see. Let's just do, or we have 1920 by 1080p. $1416. I'll just do that. Yes. All right, so this should hopefully fix it. Reboot the Pi. And this time, yes, it is actually showing up on my monitor, which is nice. And you can see right there, I've got the May 2020 release. I'm probably going to leave this video mostly unedited. I might cut out a few of the waits. But I want to show you guys kind of the process. So this stuff doesn't always work first try. And you will have to do things such as adjust to fit your monitor. So now that it starts on boot up, and I can actually grab my remote right now and drive it, which is nice, we're actually going to set up autonomous programs, which is the main purpose of this video. So we're going to open up our code here, and we're going to set our program to run autonomously. So we're going to go to robot.py, and we're going to set up autonomous functionality. And I'm just going to do that within a function. So here's my code. Look at all this. Right about here, define autonomous. I'm just going to call mine auto. Yeah. All right, with a little colon at the end, and you should be tabbed in. So anywhere in here, I'm going to write my autonomous program. And the way you do that is pretty much with these throttle commands. But instead of doing it like you did here, where you're setting it to axis 1 and axis 2, which is your remote, also, we need to take these. Get rid of the drift. Actually, I believe we can just take these and put them up here. I think this will do well. I don't think they actually need to be in the loop. Okay, now that these are up here, so they should apply to the auto function as well, is kit.continuous servo 0 and 3. So these are our two motors. So if I want it to go forward, we're just going to set speed to 1, which is full speed ahead. So we basically said both motors full speed ahead, which essentially just means drive forward. And now what we can do is right here where we're doing import pygame, we're also going to import time, so we can add timing to our event, to our autonomous program. So I'm going to tell it to wait, or time.sleep, and you can give it some amount of seconds. So I'm going to give mine 5 seconds. And then I'm going to set my throttle to 0. Okay? And now it will drive, it'll start driving, wait 5 seconds, and then stop. So this right here just means drive forward for 5 seconds. And now I'm actually going to go ahead and I want to turn. So at this point in time, let's see. What do we want to do here? So I'm actually going to set it like this. So what it tells it to do is start both of them, and then after 5 seconds, only stop one. And so that'll go forward for 5 seconds and then turn. And we're going to turn this one for another 5 seconds. And we just stopped motor 3, so now we want to stop motor 0. So we're just going to do that. And by the time it gets to the end of this program here, where my cursor is, all motors will have stopped, and we will have driven forward and then turned. So let's say that is my autonomous program. I've driven it around on the field, and that seems, you know, like what I want to do. We can then go ahead and call that code just by using the word auto. So I'm just going to tell mine to run right before we get to the controller section. So this right here is all of our controller section. And right here, I'm just going to say run auto. All right. And if we're running through the code, you start, you set stuff up, you set stuff up. We're doing our drift management thing here instead of in our loop. And then it's saying, hey, create auto. And auto means all of this. So it's just created. This won't actually do anything on its own. This line right here says, hey, go do the thing we just created. So now it'll do all of this. And then after it finishes this line, it gets to the next one, which says drive your robot. So I'm going to go ahead and run the code. Okay. All right. I think it's because I still have my startup code running. So the way you can stop that is the same way we did the other one, which is ps-ef, but in this case, I'm going to do Python. This is, after the grep is just whatever program you want to stop. And in my case, it is going to be 674. So that just killed my control. So I no longer have control over the robot. But we're going to start our code, which it drives forward for 5 seconds. Actually, I should change the view so you guys can actually see. Hold on. Let me stop this. All right. So I'm going to hit play on my code. Okay, so I'm going to hit run, and it starts. So we're doing 5 seconds of forward. And then this one stops, so only these ones are going, so it's turning. And now it's been 5 seconds. It stops, and then it continues in the code, which tells start driving. So now that it's over, I have drive controls. There's one issue with that, though. If it starts running the moment I turn it on, which is what it's currently set to do, the moment I flip the switch on my robot, it'll wait 5-10 seconds for it to start up, and then it'll just start my autonomous on its own. Which doesn't usually, I mean, you'd have to be really lucky for that to line up with the start of the match, and you'd have to time when you're turning on. Anyway, it's a bit of a hassle, so I don't want it just to run on startup. I want to be able to tell when it runs my autonomous program, and that's why I put it in this function. So instead of just calling auto at the start, we're going to call it whenever we hit a button. So I'm going to just call it down here, say if, and you see where we're getting our button, or our axis here? We're just going to see if we're hitting a button. And I'm just going to set this on button... What is it? Button 8, I believe, is the one I'm looking for. So if we're hitting button 8, then run auto. So I'm going to run this here. I don't remember which one is button 8. Let me stop. Okay. Run. So now I have drive control. Whoa. Ah. This is get axis. This needs to be get button. That's on me. Okay. So now running with get button. Okay. We have started the code, and I have full drive control. Let me go back to the robot. I have full drive control here of the robot. And so I can drive it. And whenever I push button 8, whichever one button 8 is. Ah, there's button 8. So I hit button 8, and it's doing my code. By the way, if you're looking at this on the controller, button 8, if you decide to use that, is the big center button, which actually works fine for autonomous. So... if I'm a team member, now that I've got all this set up, I've made my autonomous, and I've made my startup, I'm just going to shut this down. I'm going to unplug my monitor. I'm going to unplug my keyboard and mouse. So right here is just a freestanding robot that I can put on the floor. And I'm going to do just that. Okay. We'll re-angle the camera here to look down at the floor. We'll move the robot over. So the match has just started, or the match is about to start. I've put my robot in the arena, and I've gone and turned it on. The little lights here, when they turn orange, that means I'm good to go. So they are currently still blinking red. I'm just going to set the remote down. All right, they have turned orange. So I now have full drive control of the robot. If I push both sticks forward, I have to turn on my remote. I'm going to turn it on just by hitting the start button. Okay. If I drive forward, the robot goes forward. If I push it back, it goes back. And I can turn it, and I can do whatever I want. Okay? So let me go ahead now, and I'm going to hit button number 8. So we're at the match. We have our robot, and then the countdown. All right, the match starts in 3, 2, 1, push button 8. And my robot has taken off down out of frame. It's over there. But it's doing exactly what I told it to do, which was drive forward for 5 seconds, and in this case it hit a chair leg, and then turn, in which case it is now facing a different angle into the chair leg. But it did do exactly what we told it to do, and now as soon as it's done, I have full driver control again. I can start backing away from the chair leg. There it is. Look at that. So that is how you program autonomously. That is all. I hope you enjoyed. Let me re-angle this camera. That is all. I hope you enjoyed watching. And good luck at the competition.